Who are these folks that are shown at low X value? Okay, I'm seeing a message in the chat. Yes, the lower income group. That's exactly right. These are the lower income folks. These over here are higher income folks. That's exactly right. So the lower income folks are crowded into this left-hand side. The higher income folks are stretched out over a really large area. Okay. So what we've seen is we've introduced heterogeneity. The heterogeneity is of two sorts. One is heterogeneity in position. The other is heterogeneity in income. And we coupled the two. The heterogeneity in income here is driving the heterogeneity in position. Okay, now right now that that may seem ho-hum, but remember my comments from a few days ago. Visualization is extremely important, and it can be very insightful if you can visualize a certain situation with a certain metaphor and see the dynamics of the model put out in the metaphor. But there's also times where we use the location to drive some of the dynamics. And we're going to do that here, ladies and gentlemen. We're going to do that here. So we're going to go to Main. We're going to go down Main. And we've already set the characteristics of position for each person according to the population. But we're going to go to that same place we did in Main before and instead dictate the characteristics of the network to assume for all populations in Maine. And we're going to set it to be a distance-based network. Okay. And this distance-based network is going to be, and I'm going to ad-lib here, it's going to be 200 units. Now, mind you, the units are specified here. The number of pixels. This is 10, that's 20, 30, 40, 50 up here, across here. I'm going to specify a range of 250. So people are going to be connected with each other. A given pair of people in this population will be connected if and only if they lie within 250 spatial units of each other. Now, you may ask, well, what's the spatial dimension of this? Like, what are the units? And in fact, you can choose that. You can choose a unit system which says, okay, what does a ruler length correspond to here? What is, here it's 1 meter is 10 pixels, is 1 meter. So if you want to have some sort of physical meaning of it, you can bear in mind that right now this is set to 10 meters and you could change it. But be careful doing that, because if there's images of people, they will be relative to that same, interpreted relative to the scale, and they may appear really small and so on. So do that cautiously. Just be aware you can do that. You can have a very consistent, just like a consistent time unit, you can have a consistent spatial unit. But for now, we're going to go back to Main, and we're going to set any two people to be connected if and only if they lie within 250 units of each other. Run early, run often. So let's make sure any logic thinks it understands our model, thinks it's grammatical. Click up here. Build's completed successfully. Great. So now let's run this model, if we may. I'm going to right-click on simulation and say run. There we go. Okay. And you could be excused for saying, well, we put all this fuss into this network. Where's the network? Where is the network? I mean, I I just said connect two people if they lie within 250 spatial units of each other. I went through, okay, each of these squares is 10, so that we'd be going 25 squares. But obviously people aren't connected, you might think. You could be mistaken for thinking that, but you'd be misled. And in fact, if you go look a little bit more closely, go over here, call up this, and go down to population. And if you were to look, you could actually check in more detail, are people connected? This is someone with a really high income. They're not connected with anyone. They're a disconnected person living in their own bubble. But take a look at this person with this annual income of 18,000. They're connected with 38 other people. Count them. Person 2, person 4, person 10, person 11, person 13. They're connected with them. How about person 2 in the population? Well, it's actually the third person, but they're at index 2, 0, 1, 2. And Java counts things from 0. So you start at 0, 1, 2. This is a third person. They have an income of 496. They have 64 connections. And you might start to notice a connection here, or some association here. The higher the person's income, what does that tell us about its likely number of connections? The higher the number of their income is, does the number of connections go up or down? Anyone? Remember, the further they are out to the right, the higher their income, the number of connections will be higher or lower?
Lower.
Lower indeed. Well spoken. Well spoken. So that's exactly right. So it's very poor people are subjected to crowding conditions. And so you're saying, well, okay, well, wait a minute, they are connected. Well, where's our network? Like, where is it? Well, it's there. Let's just make it appear. It's actually there. As that showed, people are connected. They're woven into networks. It's not appearing. Why not? Let's go check. So in order to make it appear, we have to look at another attribute. Well, ain't that something? Okay, well, mumble. So let's go look at a person. Let's go look at a given person here. Here we go. Go to a person. You notice it has connections here. A person has its connections. That's what we were browsing for each person in the population, their connections. One person had 64, one person had 38, one person had 0. They were a disconnected millionaire. Okay. Here we go. These connections connect them up to other agents. We could actually be more specific and say they're connected to other persons if we want to. Probably a good thing to do. Say they're connected. Hey, they're not connected to anyone. They're connected to persons. Okay. Yeah. But you notice down here in the animation section, and it's possible you'll have to expand it. There's a thing, say, draw line connecting agents. Please select that. And then you can choose, do we draw it on top or behind? I'm not going to be too particular about this. Maybe we'll do it on top of it just so we can kind of see it. It won't be obscured. So draw line connecting agents, draw on top, and you can select what sort of color it will show the network and what sort of thickness of lines and all that sort of stuff. Okay, are we okay? We okay? Okay. So if I run it, what do you think will happen? Great, thank you, Sala. What do you think will happen? Well, there you go. There be a network, ladies and gentlemen. Tell me, based on what you're seeing, is everyone in the entire population likely to be connected? Well, there's people out here. This person is not connected. This person is connected with 3 others, but they're disconnected from the broader population, from the sort of, madding crowd, as it were. So there are these kind of components of the network, right? Maybe if we had more population, we would see a denser network. Ah, that's a good idea. If we had more population, people would be knitting together. Let's see how we can do that. Well, here's the thing. There's a unity here to this, ladies and gentlemen. Parameters encode assumptions and communicate assumptions from the point of creation to where they're used. We had person, annual income encoded an assumption about their income. In this case, it's differing. And the point of creation of that thing, the population, drew that income from a distribution. Remember that? Oh, look at that. It drew from a distribution. So agent had a parameter, and its value was determined where that agent was created, which in this case is the population. So guess what? It turns out that parameters can live in Maine too. They can encode assumptions in Maine. And where will the value of those assumptions be determined? Well, it's the thing that creates Maine. And guess what the thing that creates Maine is? Does anyone remember what I said from this seat? Not an hour and a half thus? Does anyone remember? Thence, I should say. Anyone remember what creates Maine? It's the experiment or scenario. It's called an experiment. I think of it as a scenario in any logic. That's the thing that fires off Maine with a certain set of assumptions. Assumptions for each parameter in Maine. So agents have parameters, and those parameters are, so an agent has a parameter, income, and the value of that income for each person is determined by the population in which they're located. We gave a little formula for it here. Maine can have a parameter, and the value of that parameter Maine will be set by the experiment or scenario that creates Maine. Thing that fires off Maine with a certain set of assumptions about those parameters. And a random number sequence. So, in short, we can have a parameter in Maine encoding the population. What population we want to run. And later we could do with other parameters too. What's the contact rate? What's the mean time people spend infectious? All those can be parameters in Maine. In different scenarios, different experiments can choose different values of those parameters. When it fires off Maine, it tells us, assume this about this parameter, assume that about that parameter. Just as population tells different people what to assume, here the simulation or the experiment, the scenario tells Maine what to assume. Okay, so let's go to Maine and let's add a parameter. Here we go, parameter. And this will be called population size. Maybe some of you want to call it pop size. I won't object if you want to do that. Prefer not to call it population. There's something called population there. So you want to be careful of what you name. Be careful about what you name things. Communicate intentions with the name. What sort of thing it is. Is it measured in days or years? Remember, annual income versus monthly income. It's a big difference. Being clear about these things, it helps if you name the parameters accordingly. Okay, so this is called population size. Where did I go? In the palette, I go to the agent palette and I click on this and I drag it in. In this case, I'm dragging it into Maine, not the person. It's not persons that have a population size. It's the whole model. It's Maine. It's an assumption about the whole model. Population size. But now we have to set its type. This is not a double precision value. This can't be a fractional thing. We don't have 32.3 as its population size. No. Might have then a compartmental model, but it's kind of a weird construct, right? If you have a antimicrobial resistance model and there's 0.0001 person with antimicrobial resistance, it's kind of non-physical. you can kind of squint and say, well, maybe it's a probability, but it's pretty sketchy. And so population sizes are naturally integers. They're naturally, in fact, natural numbers. We could say it's an integer. How did I do that? I clicked on this. Let me make sure it's named something like population size. And I clicked on type. Originally, it was double. I clicked here and I went upwards. Upwards. And there's things above double. And I said int. Okay. And its default value will be 100. After all, that's what we've been using till now, 100. So now we're specifying for the model a certain population size. Okay, great. Great. It's an integer. Oh, don't do 100.0, 100. That's not a stinking like partial number. It's not a fractional number. It's 100. So honest to goodness, 100. It's an integer. Okay. Okay. So that's the population size. Okay, so you might be tempted to say, population size of 100, great. Now we can have a big population and a small population. In fact, if you go over to simulation, you'll notice it says population size equal 100. Why does it say this? Where did this value come from? Can anyone tell me? Where did this value come from, 100? Why doesn't it say 110? Who typed that value in? Who typed that in? I did about 30 seconds ago, 100, right? If I had said 110 and I went to simulation, it would say 110. You know, that's just the default value. If I don't specify a value, that's the one it will use. Kind of the default. You could think of it. That's called default value. Okay. Often I choose that as the baseline value, the value that's used for the baseline scenario. So I'm saying it's 100 here. There's the simulation, 100. There we go. Okay, now I want to create another scenario. Now, a best practice here, you can actually right-click here and say new experiment. But what I like to do often I kind of futz some things here. So sometimes I like to just right-click here and say copy, and then right-click up here and say paste, if I want to carry a lot of assumptions with it. But for now, we're just going to create a new one. So right-click on the whole model, and I'll say new experiment. And I'll say, you know, population pop 1,000. I don't know. I could say big population, but that's not very quantitative. Pop 1,000. I could say population size 1,000. Okay, pop 1,000. And I could set the population size to be 1,000. But tell me, for anyone watching really closely, yeah, that was the number of initial agents. How I got it exactly. If I set 1,000, how many agents is it gonna create if I say 1,000? Anyone? Given what I've actually done, I say population size, make it 1,000. How many agents is it actually gonna create right now? If you've been watching really carefully. Anyone? I'll tell you how many it's gonna give. If I run this, it's gonna give me not 1,000, but here we go, 100 agents. Why? What haven't I done? What haven't I done? I said this is population size. I gave it a nice communicative name, and I said it's 100 by default. It's called population size. And then I said make it 1,000 here. Make population size. Make population size 100 here. But what haven't I done yet? Where is the population size actually determined in this model right now? Where do I look to find the population size? How many agents are created? We saw it, you know, an hour and 15 minutes ago. Where is operationally the population size set here? Anyone? It's the population size of the what? Yeah, it's the count of persons. And where is the count of persons set? It's in the population. Darn right. Darn right, it's in the population. It's the population size. Yeah. Yeah, it's in the population. Go to population size. Initial number of agents, it says 100. Oh, yeah. So guess what I have to put there? Guess what? Population size. Yeah. So I can put population size. Okay, now. Okay, now there's a branch. Every time I teach this stuff, there's a branch. And how picky I am. I could say population size, and it will be a happy camper. By the way, you could, better yet, have it fill it out, right? Just like that. It'll be a happy camper. Yeah, it'll be okay. It'll be okay. The truth is, if we want to be big boys and girls, often we'll say this stuff population size to be careful. It's my population size, my one. Notice I said self here. That's only when it's created. It's a very specialized circumstance. This is like my population size. And I'm not going to really push that this time, but just be aware that sometimes you want to be very explicit about whose population size. So this time I'll leave it as population size. Okay, there we go. Okay, population size. So now, if I run the regular simulation, it has a population size of 100. And if I go run it, here we go, 100. And if I go click that, come on, 100 here, 100 agents. Yeah. Yeah, sure. Maybe I'll move this guy somewhere a little bit less crowded. Like maybe I'll move it up there. And then it's just out of the way of the web of stuff, which is sort of goes down from here and right from here. And so then I can scroll and I could see, yeah, it's 100. Okay. But it's out of the matting crowd. Okay. And here's 1,000, and I can right click on it, and it'll take slightly longer to initialize here because it's got to, oh my gosh, it's out of memory. Oh no. Okay, I've got to give it more memory. I'm going to go give it two gigs of memory. two gigabytes. When I was in grad school, man, 2 gigs is like unthinkable. Okay, so two stinking gigabytes of memory there. I'll try running it, and it will show me a rat's nest of a set of connections with 1,000. It's going to take a while to create this. So it's creating this big network, and tons of agents are going to be connected with other agents and so on. Maybe I chose inartfully. Maybe I shouldn't have. Yes, I remember the 386 very well, Sala. I programmed it, and I remember all the connections. Oh, okay, it showed it only for a second. Absolutely, I remember the 386. And there are a variety of different subtypes to the 386, in fact. I also remember the 286, and I started programming on the 8088, which is a kickoff of the 8086. Anyway, okay, so 1,000's a bit much. Maybe I'll because we're connecting all these agents to everyone else, so we'll do it. You could do it, and I'm not gonna force it, but I'll say new, sure, experiment, and I say population, yeah, sure, say 200, okay. I won't tempt fate, and I'll make it a population size of 200. Okay, there we go. Because it's going to get super crowded. We're going to have agents communicating, and there's a bigger network, a denser network, right? And we could up it from there if we want to bridge this gap. And notice it's more connected than it was before, but still gets disconnected as you go to the right. Okay. Anyway, Ladies and gentlemen, we've learned about, specifying assumptions for the model as a whole, like population size. We specify the assumptions about it in, we specify the assumptions about parameters in main here in scenarios. And we specify assumptions about persons, and why in scenarios? Because scenarios create main. That's why we specify the assumption to be had about parameters in main. We specify the assumptions where at its point of creation, which is the scenario. Persons who have parameters, we specify the assumptions about that where that person is created, which right now is limited to the population. So each person, for example, here has an income, annual income, and the person is created in the population, and so we specify its income here. Okay? Yes. Okay. So, ladies and gentlemen, this is version 3 of the model. So we have heterogeneity. We have crowding based on income. We have people and networks. We have a visual representation of them. And all this is very rich, but there's not yet any dynamics of sorts. We're sort of laying out this picture with rich heterogeneity and income and location and number of connections, and all that's great, but there's no dynamics. And agent-based modeling is nothing if not a dynamic modeling tradition. So that's going to be our next query, adding dynamics. But first, I will post this model in case anyone wants to catch up. So I'm going to post version 3 to the course site forthwith. Okay, here we go. And oh, I don't want to post that yet. The videos and version 3 here will be placed up there as we speak. There we go. Version 3. Okay. So if anyone wants to resync, have that, you're welcome to. Okay. We've covered a lot, actually, of basics. We're building up. And next, we're going to handle the dynamics and see how that's handled. We already have the networks, so we're going to allow agents to communicate over those networks. And we're going to add in some visual effects to show the states that they're in. We're going to have infection spread, for example. But are there any questions that I can answer? And maybe we'll take a health break in just a moment. Are there any questions that I can answer so far?
I had a question.
Please.
So when you're when you're dragging stuff around on this sort of main screen over here, what does that do? Does it do anything? Like when you move the population?
No. Okay. Great question. So excellent question. So if I move this around, does it change the dynamics of the model? No. Does it change the appearance of the model? Yes. So the fact that I moved population up there didn't change the layout of the agents, their connections to each other. None of that was affected. And as you'll see when we specify dynamics, none of that will be affected. But it does alter somewhat the visual appearance that we see when we're running the model. Like here's the population here, and you notice where it is relative, say, to this thing. I'm just gonna show you. I mean, this is kind of a landmark. We'll see where it is and kind of relative to this. And if I went back and oh my gosh. Okay. If I were to drag this, let's say, over here, and I were to run it again, you would find that it visually appears at a different place. It's over here now. Its place reflects where it is here. And it, in general, any logic has a very sophisticated capacity, which I'm not getting into, to add things onto its canvas. So you can add in buttons that do things, checkboxes and radio buttons and sliders that change parameter values, and you can add in graphs. We've seen that some. Add in histograms and plots and time plots and pie charts and all those sort of things. And where they're located on this palette, or sorry, on this canvas, will ramify in terms of where they're laid out here, but it won't alter the model, the model connections here, their interconnections, except the model logic. It's kind of what its visual manifestation will be. Visually, how it will be rendered will be different. Things will be positioned differently, but it won't materially alter the progress or the dynamics of the model. Is that helpful?
Yes, thank you.
Yeah, sure. Other questions? Okay, maybe we'll take a 5-minute break and we'll come back in 5 minutes, just for everyone health break, and we'll continue on. Okay, so I'll stop my share and we'll see you in 5 minutes. Thanks.